Hello friends, in today's video, we will see more utility classes related topic, more interesting topics. We will start with using an argument index. Formatter includes very useful feature that lets to specify argument which a format specifier applies. Okay, format specifier and arguments are matched in order from left to right. So if you are giving %x and your first parameter or first argument is 12.34, it's suppose. So that %f will be matched to 12.34. Likewise, we have seen in C programming. The first format specifier matches the first argument, second one for second, and so on. By using argument index, you can explicitly control which argument format specifier matches. Okay. So independent upon what is the sequence is, it will tell the compiler if I am giving the index as true, that format specifier will match with that index true, not for the first argument. Okay, so that is called as argument index. An argument index immediately follows the %, like format is $n, where n is the index of the desired argument beginning with 1. Okay, so index start with 1 and it immediately follows the % in format specifier. Okay, if I am giving $3, so 3 will be your argument index. So this first D will be replaced by the index 1, 2, and 3. So here 30 will be replaced. Here $1 means first index is 10. So here 10 will be replaced, and $2, that is second index, it is 20. So it will be replaced like this. So output is 30, 10, and 20. It is not like 10, 20, and 30. So it is called as argument index. The first format specifier matches 30, second 10, and third 20. Thus the arguments are used in an order other than strictly left to right. So you will tell the compiler which index you want to specify. One advantage of this index is that they enable you to reuse an argument without having to specify it twice. Okay, so one index can be given 2 times. %D in hex is $1 x. So 255 will be given only 1 time. Okay, so this D will be replaced by 255. 255 in hex is 255 itself. Oh, sorry, FL. Okay, so X will be your hexadecimal format. 255 hexadecimal format is FL. The argument 255 is used by both format specifiers. So 255 is given only once. There is a convenient shorthand called a relative index that enables you to reuse the argument matched by preceding format specifier. Okay, so relative indexes also exist that enables you to reuse the argument matched by the preceding format specifier. Simply specify less than for the argument index. For example, following call to format produces the same result as the previous example. Okay. Format %D is hex less than %x. So, relative index that enables you to reuse argument matched by preceding format specified. Relative indexes are specifically used when creating custom time and date formats. Okay, so same output is generated using this relative index less than. Okay, so 255 is given only once over here also, and %D 255 in hex is FF is the output. Now we will see one example, because relative indexes are especially useful when creating custom time dated formats. So formatter object is created, calendar object is also created. %T E of % less than T B, % less than T Y. Okay. So output is today is day 1 of, so calendar objects 1 of January, comma 2007. Okay. So for formatting time date formats, these relative indexes less than are used. Okay. So same calendar object is used over here. It is not given 1, 2, and 3 times. It is given only once. For first, relative index is not used because the argument is present. For second, relative index is given because same argument we are using twice and same argument we are using thrice. So for the first thing, we are fetching the date. For the second argument, we are fetching the year, month, and for third, we are fetching the year. The relative indexing argument cal need only be passed once rather than 3 times. Okay. Now next is Java printf connection. There is nothing technically wrong with using formatter directly when creating output that will be displayed on the console. Okay. There is a more convenient alternative is printf method. Okay. So formatter is a replacement of C programming's printf function or printf method. But there is more convenient way still available in Java. So it is not like that Java has been removed the printf. Java still using the printf method. The printf method automatically uses formatter to create a formatted string. Okay. So no need to create a formatter object over here. It then displays that string on system.out, that is console, by default. The printf method is defined by both print stream and print writer. The printf method is described in chapter 90. Okay, that is next chapter. Next is scanner. Scanner is a complement of formatter. Okay, so scanner reads formatted input and convert it into binary form. Okay, although it has always been possible to read formatted input, it required more effort than the most programmers would prefer. Okay. Read formatter out input is done by using scanner. It required more effort than most programmers would prefer. Because of the addition of scanner, it is now easy to read all types of numeric values, strings, and other types of data, whether it comes from a disk file, the keyboard, and another source. Okay, so using scanner, now you can read all types of data. You can read numeric values, that is numbers. You can read string and any other type of data. Okay, whether it comes from disk file or keyboard or any other input source. And always it has been possible to read formatted input. It required more effort and scanner made it more convenient. Okay, using scanner class, it is very much easy now to read the input from user. So that input can be from file, so that input can be from keyboard or or from any kind of source. Scanner can be used to read input from the console, file, string, or any source that implement the readable interface or readable byte channel. You can use scanner to read a number from the keyboard and assign its value to a variable. Okay, so scanner.in we are passing while reading from the user. Given its power, scanner is surprisingly easy to use. Now we will see the scanner constructors. There is one more table available for scanner constructors. Scanner defines constructors shown in table. Scanner can be created for a string, an input stream, file, or any object that implements the readable or readable byte channel interface. The following sequence creates a scanner that reads from the file test.txt. Okay, so scanner file from throws file not found exception. Creates a scanner that uses the file specified by file from as a source of input. Scanner file from string character set throws file not found exception. Creates a scanner that uses the file specified by from with the encoding specified by character set as a source for input. Okay. Scanner input stream from creates a scanner that uses the string specified by from as a source for input. Scanner input stream from string character set creates a scanner that uses the string specified by from with the encoding specified by character set as the source for input. Scanner readable from creates a scanner that uses the readable object specified by from as a source for input. Scanner readable byte channel from creates a scanner that uses readable byte channel specified by from as a source from input. Okay. Scanner readable byte channel from string character set creates a scanner that uses the readable byte channel specified by from with the encoding specified by character set as a source for input. Scanner string from creates a scanner that uses string specified by from as a source for input. This next line creates a scanner that reads from standard input. Scanner con in new scanner system.input. This works because system.input is an object of type input stream. Then call to constructor maps to scanner input stream, and this line works. Okay. The next sequence creates a scanner that reads from a string. Okay, so reading from a string will specify the string object in the scanner constructor. Scanner con in is equal to new scanner instruction. Okay. Then next is scanning basics. Once you have created scanner object, so next thing what you have to do is to read the formatted input. Scanner reads tokens from underlying source that you specified when the scanner was created. Okay. As it relates to scanner, token is a portion of input that is delimited by a set of delimiters, which is a white space by default. Okay. A token is read by matching it with a particular regular expression which defines the format of data. Okay. So, scanner reads token from underlying source. That is first thing you have to understand. When you create a scanner object, it will read token from the underlying source that you are giving as the input source. A token is a portion of input that is delimited by a set of delimiters, like we have seen underscore, space, comma, semicolon, like this. So different parts of an inputted value they are specified by delimiters. Okay, so those parts are called as token, and those tokens will be read by scan. A token is read by matching with a particular regular expression, which defines the format of the data. Okay, because like in any string, what you are doing in any string, if the delimiter is semicolon, so between two semicolons, if suppose there is one string available, that string will be read by scanner. Scanner allow you to define a specific type of expression that its next input operation will match. It include many predefined patterns which match the primitive types such as int and double and strings. Okay. Often you won't need to specify a pattern to match. If you are not giving explicitly any patterns which match the primitive type like integer, double and string, often you don't need to specify it because there are many predefined patterns already available. If you do not specify explicitly, there are implicit patterns available. To use scanner, follow this procedure. First is determine if a specific type of input is available by calling one of scanners has next method. Okay, so input is available or not, true or false will be determined by has next method, and where X is the type of data desired. Okay, so for integer type of data, suppose you want to take an input from user. If it is still available, then it will tell you yes, it is available. Has next methods will return true. If input is available, read it by calling one of the scanner's next text method. Repeat the process until input is exhausted. Okay, one by one read them using has next available, and if it is available, it will return true. Otherwise, it will return false. Scanner defines two sets of methods that enable you to read input. The first are the has next X method, which are shown in table. These methods determine if the specific type of input is available. Okay. Has next int means there is next int available. if the next token to be read is an integer and it is available. If the desired data is available, then you read it by following one of the scanner's next methods which are shown. To read the next integer called nextInt. Following sequence shows how to read a list of integers from the keyboard. Okay. Scanner connection in new scanner. Integer I read a list of integers. Wide connection is has nextInt. I is equal to connection in dot nextInt. If available, read it. Otherwise, input is exhausted, so it is not available. Okay. So scanner methods we will see now. Boolean has next returns true if another token of any type is available. Otherwise, return false. Boolean has next pattern returns true if a token that matches the pattern passed in pattern is available to be read. Okay. So any token that matches the pattern with the pattern is specified in bracket is still available. Otherwise, false. Boolean has next string pattern returns true if the token that matches the pattern passed in pattern is available to be read. Returns false. Otherwise, Boolean has next big decimal returns true if the value that can be stored in a big decimal object is available. Otherwise, return false. Boolean has next big integer returns true if a value that can be stored in a big integer object is still available to be read. Returns false. Otherwise, the default radix is used unless changed. Default radix is checked. Okay. Boolean has next big integer radix returns true if a value in the specified radix that can be stored in a big integer object is available to be read. Returns false. Otherwise, Boolean has next Boolean returns true if a Boolean value is available to be read. Returns false. Otherwise, Boolean has next byte returns true if a byte value is available to be read. Returns false. Otherwise, the default radix is used unless change default is 10. Boolean has the next byte integer radix returns true if a byte value in the specified radix is available to be read. Returns false. Otherwise, Boolean has next double returns true if a double value is available to be read. Returns false. Otherwise, Boolean has next float returns true if a float value is available to be read. Returns false. Otherwise, Boolean has the next int returns true if an integer value is available to be read. Returns false. Otherwise, the default radix is used unless change default is 10. Boolean has next int integer radix returns true if an int value in the specified radix is available to be read. Returns false. Otherwise, Boolean has next line returns true if a line input is available. Boolean has next long returns true if a long value is available to be read. Returns false. Otherwise, the default radix is used unless change is 10. Boolean has the next long integer radix and returns true if a long value in the specified radix is available to be read. Returns false. Otherwise, Boolean has the next short returns true if a short value is available to be read. Returns false. Otherwise, the default radix is used unless change. The default radix is 10. Boolean has the next short integer radix returns true if a short value in the specified radix is available to be read. Returns false. Otherwise, string next returns the next token of any type from the input source. String next pattern returns the next token that matches the pattern passed in a pattern from the input source. String next returns the next token that matches the pattern passed in pattern from that input source. Big decimal next big decimal returns the next token as a big decimal object. Big integer next big integer returns the next token as the big integer object. The default radix is used unless changed. The default radix is 10. Big integer next big integer radix returns the next token using the specified radix as a big integer object. Boolean next Boolean returns the next token as a Boolean value. Byte next byte returns the next token as a byte value. The default radix is used unless change. The default radix is 10. Byte next byte integer radix returns the next token using the specified radix as a byte value. Double next double returns the next token as a double value. Next float returns the next token as a float value. Integer next int returns the next token as an int value. The default radix is used unless change. The default radix is 10. Integer next int integer radix returns the next token using the specified radix as an integer value. String next line returns the next line of input as a string. Long next long returns the next token as a long value. The default radix is used unless change. The default radix is 10. Long next long integer radix returns the next token using the specified radix as a long value. Short next short returns the next token as a short value. The default radix is used unless change. The default radix is 10. Short next short integer radix returns the next token using the specified radix as a short value. The while loop stops as soon as the next token is not an integer. Okay, for example, then the loop stops reading integer as soon as non-integer is encountered. Okay, so next int is available and a resistant false if it is not available as an integer, and while loop will terminate. The next method cannot find the type of data. If our next method cannot find the type of data that it is looking for, it throws no such element exception. If it is searching for int and it is finding out float, it will give you no such element exception. For this reason, it is best to first confirm that the desired type of data is available by calling has next method before calling its corresponding next method. Some scanner example we will see now. In addition of scanner to Java makes what was formerly a tedious task to an easy one. Let's look at some examples. We will see one example that averages list of numbers entered at the keyboard. Import java.util.star. Scanner connection in new scanner system.in integer count double sum 0.0 enter numbers to average. Okay. So double value should be given by user. If it is next double, take it and sum it and count incremented. Okay, so one by one count is incremented, sum is also incremented, and after that point dot next in dot next take it as a string equals done break. Okay, so user will enter float and float and float and float, and when user has been done with all the numbers specified, it will enter a string. So it will be taken as connection in dot next, and if at is it equal as done, it will break from the while loop and data format error. Okay, and average is sum divided by count. How many numbers that user has been specified as an input, that will be written as a count, and that number will be divided by sum divided by count. Okay. The program reads numbers from the keyboard, summing them in the process until the user enters the string done. It then stops input and displays the average of the number. Here is the sample done. So a user is entering 1.2, 2, 3.44 and done, and then average is 1.2 plus 2 plus 3.4 plus 4 divided by 4. Average is 2.65. Okay. The programs read numbers until user enters done. When this occurs, it confirms that token is a string done unless and until double values are entered. Program terminates normally, otherwise it will display the error. The numbers are read by calling next double. Reads any number that can be converted to a double value, including integer value also, float value also. Okay, but it should be converted to double. It can be cast to double. Thus, the number read by next double need not specify decimal point. It is not compulsory, and same rule applies to all the next method. They will match and read any data that can be converted or casted to any particular data. One thing that is especially nice, that it is the same technique used to read from one source can be used to read from another. Okay, so general methods can be used to read from another type of data. Okay, here is the preceding program reworked now to average a list of numbers contained in a text file. Okay, so count and sum is taken. File writer, new file writer, text.text. 2, 3.4, 5, 6, 7.4, 9.1, 10.5 and done. Okay, so these numbers are written into file writer using fout.write. Numbers are written on file. Then again file reader to read from file text.text. Scanner, new scanner. Okay, so unless and until it has next value, so any value can be taken. Okay, so general rule is there, as next double taken as a double and sum and then count is incremented. Else if it is not converted table to double, then it is taken, and if it is done, break from the loop, file format error, and average is counted. Output is same 6.2. Okay, you can use scanners read input that contains several different type of data. Okay, Even if the order of data is not known, only the next method you have to use. You must simply check what type of data is available before reading it. Now we will see more example. Use scanner to read various types of data from file. Scanning of mixed type data. Throws input output exception if file cannot be inputted and outputted. I double D boolean B string string. Okay. So output of file testing scanner 10 12.21 true false. So file is first of all written, then it is open for read. File source dot has next. Okay. I is equal to source dot next int system dot out dot println int plus I. Okay. Source has next double. D is equal to source dot next double colon D. Okay. So first of all, 4 types of ifs are created. If it is int is displayed over here one by one in while unless and until has next data is available. If it is int convertible to int is displayed. If it is double convertible to double is displayed. Boolean is displayed or since string is displayed. Okay. String testing scanner 10 double 1 true 2 false. Okay. So unless and until data is available, it will iterate and it will cast to a particular type. If it is int, it will display it as int. If it is double, it will display it as double or string or boolean. Okay. So there is a mixed data. You need to be careful about the order in which you call the next methods. Okay. If the loop reverse the order of calls to next int and next double, both numeric values would have been read as double value because double can accept integer. Okay, the X double matches any numeric string that can be represented as double. So you have to take care of the order. If you will first read the next double, so integer will be also treated as double and integer double will be also treated as double. Now we will see string delimiters. Scanner defines where a token start and end based on a set of delimiters. Delimiters are underscore, space, comma, semicolon, etc. etc. Default delimiters are white space characters, and this is the delimiter set that the preceding examples we have seen. But we can change the delimiter by calling the use delimiter method. Scanner use delimiter and pattern. Okay. So scanner use delimiter pattern. So there are two constructors, two methods are there. One is having string pattern, second is having pattern. Pattern is a regular expression that specifies the delimiter set. Okay. So now we will again build the average program now that reads a list of numbers that are separated by commas and any number of space. Okay. So you output of 5 to 3.4 comma space 5 comma 6 comma space 7.4 and etc. etc. Now use delimiter comma and star. Set delimiter to space and comma. Okay. So this is the method. Scanner object dot use delimiter method is available comma and star. Okay. Why source has next? If source is next double, it is double value, then it is summed up and then count is implemented. And if it is done, break out, average is sum divided by count. The numbers returned to test.text are separated by commas and space. The use of delimiter pattern, comma star tells the scanner to match a comma and 0 or more spaces as delimiters. Okay, so output is same as before. Okay, so current delimiter pattern you can find out using the delimiter pattern delimiter. It will return you the pattern. Okay, last is other scanner features. Scanner defines other methods in addition to those we have already seen. One that is particularly useful in some circumstances is find line method. Okay, string find in line pattern, string find in line string pattern. So first is pattern, second is string pattern. This method searches for the specified pattern within the next line of text. If the pattern is found, the matching token is consumed and returned. Otherwise, null is returned. Okay, so it will find in the particular text line. it operates independently of any delimiter state. Okay, so you can specify any pattern you like. It is useful if you want to locate specific pattern, by we will find out the find in line. Name, Tom H colon, name colon Tom H colon 28 ID colon 77. Scanner object is created. The instructor is passed over here because it's the constructor. Con in, find in line H colon, find H. If con in has next, get next, and otherwise it is error. Okay. H colon is find out here. So H colon pattern is find out and output is 28. Okay, so after this, if it is having anything next, it will be displayed as a output, and output is 28. Find in line used to find occurrence of the H colon, and next token is read after H colon, and it is 28. Related to find in line, find within horizon, pattern, integer count, pattern, integer count. Two methods are available. This method attempts to find an occurrence of the specified pattern within the next count character. If successful, it returns the matching pattern, otherwise it returns none. If count is 0, then all input is searched until either a match is found or end of input is encountered. Okay. What this method does, it attempts to find an occurrence of the specified pattern within the next count character. So how many counts that you have specified? For example, if next 10 characters, how many times the star has been occurred, how many times the string age has been occurred, how many times that space has been occurred, or anything, any pattern you are specifying, that is how many times within the number of characters, next count characters it is occurred, it will return. Okay, it and sorry, in that next count character, if it is available in next horizon, if it is like H colon is available, occurrence is there, it will return the matching pattern, otherwise it is returning null. If count is 0, then all input is searched for all next line until the either match is found or the end of line is encountered. Then bypass a pattern by using skip pattern and skip string pattern. If the pattern is massive, skip simply advances beyond it and returns a reference to an invoking object. Okay, so it is skipped, and if the pattern that you have to skip it is not found, then it will throw the no such element exception. Okay. Other scanner methods are radix, which returns the default radix used by scanner. Second is use radix, which sets the radix. Third is reset method, which resets the scanner. Close, which closes the scanner. Okay. So this way we have completed some new topics, again related topics to more utility classes, some interesting classes. Okay. So in the next session, we will finish with the remaining topics, and then we will move forward with the practical part. So meet you in the next session. Till then, enjoy utility classes. Thank you so much.